Hi everyone, in this video you have to find f of 1, f prime of 1, g of 2, g prime of 2, but using the definition of the derivative, because the given thing in these questions is limit for a function. So you have to compare this function by the first definition of the first derivative or the second definition of the first derivative. So we'll start with part A, and part A, suppose that limit f of 1 plus h divided by h when h goes to 0 equals to 5. You have to find f of 1 and f prime of 1. So by direct substitution of, if you replace h by 0 in our function inside the limit, you'll get f of 1 plus 0 divided by 0 equals to 5. And this gives us that f of 1 divided by 0 equals to 5. Now if f of 1 equals a number not equal to 0, then it will be like 3 divided by 0, which is undefined. So the answer will be infinity or negative infinity. Since the limit equal 5, which is a number, so the direct substitution inside limit must be 0 over 0. So you can use you can use cross multiply. You'll get f of 1 times 1 equals to f of 1 equals 5 times 0 equal to 0. So this is the first part of our question. Now you have to find f prime of a. So you have to rewrite the function or the limit in this order. We have limit f of 1 plus h divided by h when h goes to 0. We can write minus 0 here, because if you add or subtract 0 from anything, it will be the same. But 0 is f of 1, so we can write this limit as limit f of 1 plus h minus f of 1 divided by h when h goes to 0. And this is by compare this limit by the first definition of the first derivative. You will see that this limit equals to f prime of 1, and that limit equals to 5. It's given in the question. So f prime of 1 equals to 5. So f1 equal to 0 and f prime of 1 equals to 5. Now when I go to the second part, in part B, the question is, suppose limit x to the third power g of x minus 24 divided by x minus 2 equals 28 when x goes to 2. Find g of 2 and g prime of 2. Now with the same manner strategy as in part A, you have to use direct substitution, and you have to replace 2 for the inside function. You will get 2 to the 3 equals 8 multiplied by g of 2 minus 24 divided by 2 minus 2 equals to 28. So we have 8 g of 2 minus 24 divided by 0 equals 28. Since the limit exists, so the numerator must be 0, or you can use cross multiply as in part A. So the numerator equal to 0, and we have 8 g of 2 minus 24 equal to 0. Add 24 to both sides, you will get a g of 2 equals to 24 divided by 8 both sides. It will be g of 2 equals to 3. So this is the first part of our question, and we did the value of, find the value of g of 2. Now we will go to find g prime of 2. How to find g prime of 2? You have to simplify the limit. Now we can rewrite our limit as limit of x to the third power multiplied by g of x minus 24. Now 24 we can write it as 8 times 3, but 3 is g of 2, so we can write it as 8 g of 2. So 24 is 8 g of 2 divided by x minus 2 when x goes to 2. If you compare this limit by the second definition of the first derivative, you will see that this limit equals to the derivative of x to the third power times g of x. So name this function x to the third power times g of x as f of x, then this will be equals to f prime of 2, and our limit equals to 28. Now we have f of x equals to x to the third power times g of x. Now by differentiate both sides, you will get f prime of x equals to, pay attention here, you have to use the product rule to find the derivative of this function. So it will be u prime v plus uv prime. So the derivative of u is 3x squared times g of x plus u, which is x to the third power, times the second function. So this is f prime of x. Now we want to find g prime of 2, so you have to replace x equals 2 in the first derivative of f. So f prime of 2 equals 3 multiplied by 2 squared, which is 12 times g of 2 plus 2 to the third power is 8 multiplied by g prime. This is g prime. So we have g prime of 2. We want to find g prime of 2, so it will be the same g prime of 2. Now g of 2 equals to 3, so, and f prime of 2 equals to 28. So we have 28 equals 12 times 3, which is 36, plus 8 g prime of 2. And hence